So I would like to show some demos on Prolog, how things work. So I will be using a version called SWI Prolog, SWI Prolog. There are many other versions on the web like Borland Prolog and GNU Prolog, and so many versions are there. Basically, Prolog is a logic language. So all these logical operations are possible when you have some kinds of information or facts. That is where logical languages come into use. So let me show you how it looks. So this is my SWI Prolog, and you have an interface. You can go to the, if you're having laptops, you can try along with me. So how do I mention some things? Like in Prolog, everything is mentioned in terms of all the small letters are constants or terms and functions, and whatever you give in capital letters are considered to be variables. So you have some facts. You know that logical languages are used in Prolog. You studied in your text that it is an AI-based languages used for logical inferencing, chatbots, gaming, and kind of things where you have rules for doing the next statements, right? So here I'll be giving some facts and then I'll be questioning. For example, I want to say some facts. Gold is valuable, silver is valuable, platinum is valuable. So I have these kind of text over here and I save it in a file called, so you can see here, I have saved this in a file called pplg prolog, right? So here so this is my compiler and the Prolog shell. From there I can find like, okay, if I want to know is gold valuable or not, then I have to give it like it's giving me true. So it says that gold is valuable. This doesn't mean that brass is not valuable. It is giving false because it is not in your knowledge base. So is brass valuable or not? You have not specified specifically that brass is not valuable. But in the set of valuable, there is no item called brass. That's why it's giving me as false, right? So whatever is there in the knowledge base will we consider to be true. Okay. So we have many things that we can represent in the knowledge base. So for example, here I have given a set of relationships. Mary hates Jane, Tom hates John, Mary hates cat, and then I have some relationships like, so I can have like, what does Mary hate? If that's my question, then I have to write so Mary hates Jane. So if I give another new line character here, the code will end. But if you want to know all the characters that are the other outputs of this statement, then you need to give a semicolon. Mary hates, oh sorry, Mary hates Jane, then I give a semicolon, and Mary hates a cat, and then I come back to prompt again. So when I give a semicolon, the code keeps going. So this is the way we extract information from facts. So X is a variable over here, and that's going to take different values. You can download this SWI Prolog. You can go to this website. You can go to this website and download the SWI Prolog, whichever version you want for your, if it's Linux or so you can download the suitable version and then you can, I'll give you some 2 minutes. Those that are having this can practice along with me. I know, of course, nobody is going to use Prolog in your lifetime for doing this. There are so many good packages in Python and Java that can build a chatbot or whatever software you want. It's only about, if you're going to do the new package entirely, then you can have an idea about how to construct a new package from the scratch. I hope now you would have got an idea about how to store facts. After seeing the way SWI Prolog is working, I hope you would have got an idea about how to store facts, how to store predicate logic, how to infer facts from them. I'll show you some more examples. So it will be really interesting if you can do some new things from the scratch so that you can defend in terms of memory consumption or the execution speed. You can develop a new package that is more faster than AIML or already available packages. That's where programmers come into light, right? So you have to challenge the community saying that I'm giving a new package in Python or a new package in Java that's going to give you a better logical inferencing mechanism. And for that, this can be your root idea. These kind of things, root older languages can give you ideas from where you can bifurcate and start with new paradigms or new packages. So now I have another set of facts here. See here. So heads. By the way, you need to type all these facts in a separate file. You need to store it, save as a file name .pl. You can see here, I have several files. You need to save as a file name .pl in your files. And then you have your compile, you need to compile it. Okay. Once after compiling, you can see the effective running of the same code or knowledge base in your Prolog editor, Prolog shell. Okay, so now coming here, I have a set of facts. These are the people whom they hate, and these are the people. This is a relationship near. Mary is near Jane, Mary is near Cat, Thomas near John, and so on. Okay, so I have a rule here. A person X will murder a person Y if X hates Y and X is near Y. So this is how I specify a proportional rule. I don't know. I hope now you got the sense of it. Okay. So if X hates X and X hates Y, then the person is near. Then he will murder. So if you want to know who is near who, if who is near Jane or something like that, you can use our usual thing. There's no one near Jane. Who's near Mary?
Jane and Cat, sir.
Yeah, I'm just showing that. So Jane, and I give a semicolon, and Cat is near Mary. So whom will Mary murder? What's that? Or let me ask, whom will Sam murder? Will Sam murder someone?
No, sir.
Yes. Well, Sam will not murder anyone. Whom will Mary murder?
Jane and Cat.
Yeah. Who will murder the cat? Mary. So these are the ways you can get inferences from a set of knowledge facts or knowledge that is stored in a database. Okay. So you have a lot of, I have another set of knowledge base over here. Who owns what? John owns a book whose title is title 1 and author 1. Mary owns a book title 2, author 2. John owns a book title 4, author or author name 1 and name 2, so on and so forth. You have so many facts like this. You can in fact query things here like that same way. And also you have functions that can do this. Like see, for example, I given the population of China is this. Population of China, population of India, population of US and Germany. And the area of China is this. Okay. Then I can use some functions for calculating the density. Okay. So for example, if I give so the density of China is 10, population density of China is 10, population of the population density of India is 21.5, population density of USA is 2.5, and population density of Germany is 4.5. So how do I do that? So population is here. Is my screen visible, or do I need to increase the size? Is this fine?
Fine, sir.
Okay. So population is going to take X, the country which you gave, and P is the pop. Pop is, it's going to call the country X, it's going to call this country X, and this pop variable is going to have what? This 100 over here, right? So this 100 will come over here in this variable pop. And this area is going to be computed based on the country that you sent. You're going to send India, means India will be the country, and it'll take the area from this. For India, what is the area? AR is 4. So this variable AR, as I told you, all capital letters are going to be variables, right? Even though country should be represented in the capital, you cannot give it as capital. Once you give it as capital, it will be considered as a variable. It will show you some syntax errors. So here you see AR is the area. You have 4, 10, 12 and all. And these areas are going to come into this variable. Then Y is the variable I'm going to return. It's going to give me population per area. That is the density. We are calculating population density, right? So it's going to compute the population density, and each population density is returned. You can even do this. What is the population density of India? That's it. So what is happening here? X is bounded to the value India, and Y is bounded to the variable pop, right? And when you're calling this, oh, I'm using my finger. X is bounded to the variable India and Y is bounded to the variable pop. And when you're using this variable pop, this pop is getting the value 85 from here by calling this. So then area, X is bounded to the variable India and AR is bounded to the variable AR is bounded to the variable X is India and AR is bounded to 4. So now pop is 85 and AR is 4. 85 by 4 is what you get over here. Clear with how the logical programming works in Prolog? So this is an example of a family. So who are the child and who is the, you can see here, Gopi is the child of Ram, Monica is the child of Ram, Chetan is the child of Virat, Kiran is the child of Manish, Swami is the child of Gopi, Ram, Gopi and Manish are male and Vedan is a male. This should be small letter, by the way. Soumya, Monica are female and so on. So these are the facts. And what are the rules? If Y is the parent of X, then X is the child of Y. So these are the rules. If this is a if then else condition, right? If child X is the child of Y and is a male, then if Y is a male, then Y is the father of X. How do you define a grandfather? He should be a father and the parent, right? Grandfather of X comma Z is going to be the grandfather of Z is going to be the X should be the parent of Y and Y should be the parent of Z. So X should be the father of Y and Y should be the parent of Z. So having said all these rules, right? Then you can ask who is the grandfather of Chetan, or who is sister of Soumya Kama, this is sister or not. So all these kind of inferences can be made. Okay, you can try out these examples in your system. This is a very almost the same example that I gave you. Very simple. Adding rules. So general propositions in the world, how do you encode it? John likes anything that Mary likes. So that anything should come in the terms of a variable that's given in a capital letter. So whatever Mary likes, then John, if Mary likes X, then John also likes X. So before that, what should I have in my facts? Likes Mary, ice cream, likes Mary, water, likes Mary, juice or something like that. Okay, all these things should be already available there. Only then if I can put John likes something of X, then it would turn out whatever Mary likes, John will also like. Provided this rule is also there in the John likes juice. Why? Because Mary likes juice. What are the things John likes? Yes, you got the essence of it. Fine. So I'm teaching this not with an intention for you to go and use Prolog because these are already obsolete. But try to use these kind of logics and programming paradigms for generating new packages or generating even more efficient ways by which you can do things better. So when you come to programming, don't use a default package. Why don't we try something new? Why don't we try something new and challenge the other package fellow saying that okay, this takes lesser time than yours. Why don't you find a research gap or a gap in the previous package saying that when I have thousands of lines to compile in AIML package, it takes so much of milliseconds for you to compile, but mine is going to take a lesser second because I use this kind of structure. Okay, for that you need to first of all analyze what structures he has used, and then you have to find out some gaps over there and see, check out what are the gaps, how we can overcome them, and then you can think of doing these things.